All right. Before we get to the next section, I just want to review the fact that we have the three main trig definitions and the three other trig definitions, which are the reciprocals. If they tell you that the tangent of theta is equal to 3/5, what would the cotangent of theta be equal to?
5/3.
If they tell you that the sine of theta is equal to 4/5, what would the cosecant of theta be?
5/4.
Okay? If they tell you that the cotangent of phi is equal to 7/2, what would be the tangent of phi?
2/7.
Okay? 2/7. So these three main trig functions and then their reciprocals are how we find the other functions. Good?
Yes.
All right. Okay? Now, one last problem. What if I tell you that the secant of an angle is equal to 8/7? What trig function would be equal to 7/8?
Cosine.
Very good. Cosine of what angle?
Theta.
What angle is that? Starts with a T?
Theta.
Theta. Very good. All right, good job. So these again just points out the reciprocal property. You have your three main trig functions, and then the other three are just the reciprocals of our main functions. Now, that brings me into our next topic, which is the Pythagorean Theorem. Some of the times when you're given a triangle, you're not going to be given the measure of all three sides. Okay? So let's say I give you this triangle right here, and I tell you that this side here, side little a, is equal to 4 inches, and I tell you that side B is equal to 3 inches, and I ask you to find the hypotenuse, which would be lowercase c, what would that be? Okay? So a lot of times they may give you two of the sides of a triangle, and they might ask you to find the third side. Okay? Now, you can only use the theorem we're about to use if you have a right triangle somewhere in your triangle. One of the angles must be a right angle, or you cannot use the theorem that we're about to introduce. Good? All right. So, if you know two of the sides and you're missing one of the sides, or for instance, let's say you have this triangle here, and I tell you that this side here is equal to 7 inches, and this side here is equal to 24 inches, and I ask you for the hypotenuse. Okay? Again, we're missing the hypotenuse. If we know two of the sides and we're looking for the hypotenuse, we can use what's called the Pythagorean Theorem to find the third side, in this case, the hypotenuse in both of these triangles. Now again, one of the three angles must be a right angle in order to be able to use the theorem that I'm about to introduce, called the Pythagorean Theorem. Pythagorean, okay? And as Marcos might have stated earlier, the Pythagorean Theorem says that c squared, little c squared, is equal to little a squared plus little b squared. So these are only sides. None of these are angles. That's why they're all what kind of letters?
Lowercase.
Lowercase. So we're only talking about the sides here, not the angles. So this is saying if you take one of the sides and square it, and you add it to the other side squared, you're going to get the hypotenuse squared. Okay? Now, this is what we do is the hypotenuse is always opposite the right angle, but we have a name for the sides that are not the hypotenuse. We call those the legs. Okay? So in these problems here, in these two problems, problem 1 and problem 2, we're looking for the hypotenuse in both of those problems. But we could get a problem where we're looking for one of the legs, okay? We may get a problem that says that we have this side, the hypotenuse is 13 inches, and side A is equal to 12 inches, and they want to know what side B is, all right? So here we're missing one of the legs. Again, the sides that are not the hypotenuse we call the legs. So we could either be looking for one of the legs, or we could be looking for one for the hypotenuse, okay? So in Pythagorean Theorem, you know two of the sides, and you're going to find the third side, okay?